Now we're ready to look at some polynomial functions.
So let's throw in a few reminders here, just so you know what we're talking about. Polynomials are functions where each term has at most one variable to a positive integer. Where you got it written? There you go. Now, polynomials can be written in this form, where f of x equals ax to the n plus bx to the n minus 1 plus all the way out to some constant. Now, the degree of a polynomial is the highest variable exponent. And again, the general format is that they're in descending powers. For example, we might have 7x to the 5th plus 9x to the 4th minus 8x squared plus 7x plus 1. Notice it doesn't have an x to the 3rd or an x cubed. It just has to go down in order. The leading term and the leading coefficient is the first term and or coefficient in general format. Okay. So again, that leading term will have the highest degree. End behavior. When asked to describe the end behavior of a function, we are determining where the output, okay, which we often think of as the y, where the output is approaching as we go out left and right. So the notation for this, we might say as x is approaching positive infinity, f of x is approaching something, question mark. And as x is approaching negative infinity, in other words, going to the left, our function f of x is approaching what? So as our x is going right or as our x is going left, our y is going where? So let's do a couple examples. We want to give the end behavior of these following two graphs. The nice thing about end behavior is we don't care what's happening in the middle. Okay, we're only looking at the arrows at the ends as we're going left to right. So in this first example here in A, we can focus to the left. Let's say as x is going towards, we can do the negative infinity first. As x is going towards negative infinity, another in this direction here, where is our y going? It looks like our y here is going down towards negative infinity. So as x is going towards negative infinity, f of x is also approaching negative infinity. Then as x is approaching positive infinity, in other words, x is going out this way, as x is getting larger, our y is also approaching negative infinity. Since they're both approaching negative infinity for your y values, you could write it as x is approaching positive or negative infinity. In other words, you're looking at both directions. F of x is only going towards negative infinity. So you can combine it like that, but only if your graph is going in the same direction, both ways. If we are looking at this function here, let's focus as x is going towards the left. As x is approaching negative infinity, which is this direction here, I want you to notice that the y isn't approaching positive or negative infinity. It's not going up or down. It actually seems to be getting really close to this y value, which is 1. So look more towards that horizontal value. Is it going up and down, or is it going left to right? Okay, so it's approaching a y value of 1. So f of x is approaching 1. Now let's do the right-hand side. As x is approaching positive infinity towards the right, well, this guy seems to be approaching the x-axis, which has a y value of 0. So f of x is approaching 0. Because the y values are approaching two different numbers, I can't combine them, as x is approaching positive or negative infinity, because they're going towards two different values. Now, here's something to note. Polynomials will always follow the end behavior of its leading term. And this is going to be very helpful when you're given certain equations instead of graphs.